more advanced romplers, things that work out of ROM, or soft synths, which work out off the PC, is now what you can do is you can actually have different samples for different velocity levels.
Oh, yeah.
So, like a common thing would be is to take that 127 and break it up into 4 ranges, and then so it's if it's a piano, you've got the banging on the piano, high velocity stuff, and you've got the playing on the piano gently, low velocity in these ranges, and then you use the velocity value within that range to set the volume. So that, and you can even use it to set the mix between the different samples, so that if you smack between lightly played and moderately played, you may blend the two to get something that sounds more like what you'd expect. So they try to use the velocity to make it more natural sounding.
Yeah. But when I took instrument design, and you mentioned this too, like the trumpet doesn't play louder, you've got more harmonics, which is not a linear.
Right. Yeah, that's one of the things that they had to do with not only with synthesis, where they tried to use the velocity to actually change the parameters going into it, but now since they've been focusing more on recorded sounds, you have to have a batch of recorded sounds. Okay, so this is what I'm talking about, aftertouch. Aftertouch is useful, and it's actually very useful for simulating like wind instruments on a keyboard. Because the piano, you hit it, the way the piano works is, when you press on the key, it makes the hammer hit the string, release it, and then as you hold the key down, it holds the damper off it. Obviously nothing's happening to the key, it's just natural ringing. But with a trumpet or clarinet or something, yeah, it keeps going based on the performer's breath. So aftertouch gives one way of controlling that you hold down the keys, and depending on how you hold down the keys depends how the note sustains. So, and there are a couple ways of doing it. Polyphonic key aftertouch applies to a specific key. So, if you're holding down a C chord, right, you get 3 note on commands for C and G. And then the aftertouch, as you push down on each one, can be independent. So it can give aftertouch command on C, E, or G. And they'd all be independent, so you could let the G fade out and keep the C and do whatever with the E. But it gives you a lot of control. It also means a lot of data. And at 31 kilobits per second, that'll clog you up. So the other thing they have is channel aftertouch. And this is a little bit cheaper to do, a little bit easier, but it has a couple questions as to how it's implemented. They basically have one pressure value for all keys. So it's some kind of average. So the question is, well, how is it done? How is the averaging done? Is there configurability over that? That's a trade-off. And I don't know whether, certain controllers have one, the other, or both, or if they're programmable. Okay, so now I'm going to talk about, I've been specifying controllers as devices. Really, there's another part of the MIDI standard. It's called a controller. Okay, so a controller in this case is more a functionality in the device as opposed to a device you use to control something else. So control, like common controls would be like volume or modulation, sustain, etc. If you look at like this keyboard, right? You've got the pitch bend, which is a very specific controller. You've got the modulation wheel, which is connected to a different software controller. And then you've got 8 generic knobs that can be assigned to any controller. So you could assign it to, something like, the modulation gives you kind of a depth of modulation. You can make one of these like speed of the modulator or something. So we'll talk about that a little bit. And the controllers are used for all notes on the channel. So you can't have a controller per note or anything like that. All right, so the controller command is 3 bytes. The command byte that says this is a controller command. The channel, again, every channel is independent. The controller ID specifies the controller. So that's a 7-bit number that tells you which controller it is. And we'll look at some of the more common ones. And then a value field. And the way this works is, since it's a 3-byte command, it can't be any longer, but you may want to have a lot of levels. There actually are often 2 addresses associated with the same controller, so that one of them is the least significant byte of the controller and the other is the most significant byte. So for instance, if you look at the modulation wheel, which we talked about here, like this is often used for, like, say, vibrato on a Leslie patch. You write the most significant byte to control the controller at hex value 1, and then you write the least significant byte to the controller at hex value 21. So they're always offset by 20 hex. And so this means instead of getting 128 gradations between things, you've got 2 to the 14, right? Because you've only got 7 significant bits, so you get 16K. But you can also just modify the MSP if that's what you want, so you can go back to 128. So it's a nice, simple method. There are also some controllers that were strictly binary. So instead of 128 or 127, you've got 2. So anywhere from 0 to F is 3F is off, and 40 to 7F is on. And those are useful, like the damper pedal is an example that you use there, where either you let the string sustain on the piano. You know what a damper pedal is on the piano?
Oh, yeah.
Yeah. So you either let the string sustain or you let off and you die. And actually, most keyboards will have a 1/4-inch jack for that. So like this, that's a sustain switch.
Oh, yeah.
So you plug that in, so when you press and release that switch, it sends the binary command to the controller for the damper. This one's also got a button that will allow you to do it, because it's meant to be wireless and not that flip switch. All right, so some common controllers. Don't worry about the 0. So controller number 1 is the modulation wheel. Controller 2 is a breath controller. And that's kind of an alternative to aftertouch. I didn't know about this until recently, but a lot of keyboards will actually have a analog input for what's called a breath controller. And the breath controller is a device you can buy where you can breathe into it, so that while you're playing, if you want to simulate a trumpet or a wind instrument, you actually use your breath to simulate it. Yeah, it's pretty neat. I'd like to get my hands on it, but I think that'd be a fun way to play with stuff. You could do some interesting things. And I'd actually be curious as to what the physical method it uses, because if it uses a tube or something, you could do talk box, like stutter effects by biting on it, and all kinds of fun stuff I think is available. There are foot controllers, and then you get like 5 and 65 portamento. You know what portamento is? I don't know. Yeah, I don't know where that term came from or when it became common, but it was something I remembered a lot of smaller keyboards had. It's basically a very mechanical sounding slur. So if you were to play, 2 notes on the keyboard with portamento on, it would slur from one to the other, from one pitch to the other. And so you could actually turn that on or off, but then you could also actually specify how long it takes to do that.
Yeah, there's I think I use mostly Garage.
Okay.
And for some of the things will have like a glide time for like since get one at a time. And
Right.
It's really fun when you have like the low C all the way to the high C with a really long time.
Okay.
Siren sweep. Yeah, that's what it's for. They just go like glide.
Okay, well, that's interesting. Yeah, I haven't heard the term portamento used a lot lately. Glide is better. Most controller main volume that's used, and that's used a lot again with a lot of guitar equipment. Like my PV unit takes 2 volume pedals, 1/4-inch analog volume pedals, and it sends common controller commands on the controller set, the main volume. Okay. Now, there's one controller that is just so common they gave it its own command. That's the pitch bend controller. So normally, if you're sending a controller command, right, you have to send the command, the controller number, and then the MSB, and then the command, the controller number, and the LSB. So that's 6 bytes. With